In this video, I want to talk you through the two-way ANOVA. The two-way ANOVA is used to estimate how the mean of a quantitative variable changes according to the levels of two categorical variables. So you're looking at a quantitative response and you're looking to see how it's affected and how it changes based on two categorical variables. So you use a two-way ANOVA when you want to know how two independent variables in combination perhaps affect a dependent variable. Remember again to check your assumptions, and you can find these on that two-way ANOVA worksheet that's available in Canvas. So when might you use this and how might it differ to a one-way ANOVA? So remember, a one-way ANOVA is just testing the means of more than two treatments, whereas this is testing the effect of two categorical variables on a response variable. The example I'm going to work through in R is actually the example that you've got in your workshop. So I think it just needs a bit more explanation. So here we're looking at the effect of pH and Kaluna present on Festuca. So we've got our two categorical variables here, effective pH, and then Kaluna presence as well. So let's have a look at how we would do that in R. So first of all, I'm going to have a look at setting up my session. And choose my directory and open that. So you can see that I'm in my ANOVA working directory. I'm going to read in my data set, so Festuca. I'm just going to have a look at the names. So we've got weight, pH, and Kaluna. I'm just going to have a quick look at what that looks like. So we've got weight, we've got pH, so 3.5 or 5.5, and then Kaluna, and this is whether that is present or absent. First of all, it'd be good just to have a look and see, using a box plot, what's happening with that data. So this box plot function will be familiar to you from the data visualization and the t-tests. And we've got that weight against factor Kaluna. So plotting weight, that response is a factor of Kaluna absence or presence. And this is what you will have covered before. But we also have added in pH this time, so plus pH, because we also want to have a look at how it differs by pH. And we're telling R we want to use that Festuca data that we've already read in. So if I run this, obviously you can tart it up a bit more using those data visualization techniques you've used, so you'll probably want to change this axis label. You can have a look how weight has changed with the presence or absence of Kaluna and based on the different pHs. So when Kaluna is absent and the pH is 5.5, weights tend to increase. We now want to test that and have a look, and we'll be using the linear model, which is something you will have seen with the one-way ANOVA. So we set up our model as we did before, and then we use our linear model, and we're looking at our response variable here, so our weight, and we're looking at that as a function of trying to predict what will happen to it based on pH. And we're also looking at the effect of Kaluna as well. So before you would have just done weight against pH, but because we're looking at another variable, we just go add, so use the plus button and add Kaluna. So this is looking at the effect of pH and then Kaluna separately on weight. And what this bit here means that we're looking for an interaction. So we want to see whether based on the pH and whether there's Kaluna present or absent, does that change that response variable, so weight. And again, we're telling it that we're using that Festuca data. So if we run that, we can see our model has appeared. And like with the one-way ANOVA, we can just run the model, and we can see, and you can just get the coefficients and the intercepts. So what you want to do to check the assumptions is just have a look at the plot. So we're just going to plot out that Festuca model. Normally it gives you 4 different plots. Using which equals 2, essentially I'm telling R I just want to look at that second plot. And this add.smooth is false, so we're not adding any smoothing. So the second plot is a QQ plot. So this has a look and sees if the data points fit on a straight line. You can see there's a little bit of a smile here, so it's got a bit of a dip here. These points are off, so you might want to think about transforming it. And then the third plot again, so we've used that which equals 3, we're having a look And you can see that there tends to be no sort of pattern here. So we're just looking at the scale location, the standardized residuals, and that seems to look okay. So we're going to say, just by eyeball, this seems to be okay to proceed with the two-way ANOVA. So these next few sets of code will be familiar to you from the one-way ANOVA. So we do our ANOVA, and you can see that actually there is an interaction term. And to find out a bit more about these and to help you understand them a bit more, there's a section on this on the two-way ANOVA workshop. So we know there's an effect here in the interaction, but we want to have a look at where that interaction lies. And before you just did it on one variable, you can actually, using the Tukey HSD, calculate that based on this interaction term. So we're going to use that AOV function again that you used before. And here we're doing that Tukey HSD using that model that we've just created. Using which equals pH and Kaluna, we're having a look at just that interaction term. If you didn't want to and you just wanted to look at Kaluna, you would get rid of that pH. So if we run this, you can then see that it spits out that Tukey multiple comparisons test that you've already done, and it spits it out just for those interaction terms. So you've got pH 5.5 absent compared to pH 3.5 absent, and you can have a look at these p-values. So here you can see some significance. These two aren't significant. There's a bit of significance here, but there isn't here. What you can do, and what you will have done with the corn crate data, is you can just visualize that a bit better and have a look at which group is the odd one out. So I've already installed the Agricoli package, so I'm just going to run it and pull it through. That seems to work okay. And I'm just going to do that Tukey test based using the treatments, and we've created a list here using this C of pH and Kaluna. If we run this, you can see that it's given it to us and for just that interaction term, and you can see that here the letters are different. It means those groups are statistically different. So you can see that that pH 5.5 and absent is statistically different to the other groups, and that seems to be what that plot suggests, because remember, you've got pH 5.5 and absent is all the way up here, so it does appear that this would be different to any of the other groups. That was just a quick run through of a two-way ANOVA in R.